Now 11 looks easy. However, the problem is, sure, the left side is factored. However, what is it equal to? It's equal to 2. And 2 is not going to work for our zero product property, right? It's not the 2 product property, it's the 0 product property. So I can't just say x plus 2 equals 2, x plus 3 equals 2. Neither one of those factors has to be equal to 2. So this is actually a little bit more work here, right? I would first have to multiply this out, right? Multiply out the left side. And when I do that, I would get x squared plus 5x plus 6. And then that's equal to 2. And now I would set it equal to 0. So I would subtract the 2, and I would have x squared plus 5x plus 4 equals 0. And now I will try to factor it. And this one is a little bit easier to factor. Why? Because the lead coefficient is just 1. Right? You don't see it, but there's really a 1 there. And when there's a 1 there, it makes the problem easier, because then all I have to do is find numbers that will multiply to 4 and add to 5. So what numbers will multiply to 4 and add to 5, right? I usually just write this. I say, what times what will equal 4 and at the same time add to 5? I mean, this is obvious, right? 4, 1. 4, 1. But it's not a bad idea, just, to write that out. Because it's kind of like a check then. Alright, 4 times 1 equals 4, check. 4 plus 1 equals 5, check. But now the nice thing is, I'm done basically. Those numbers give me exactly what I need inside my binomials, positive 4 and positive 1. And what goes at the beginning of the binomials? How do you get x squared? X times x. So it's just x plus 4 times x plus 1 equals 0. And now, apply the 0 product property. So x plus 4 equals 0, x plus 1 equals 0, so x equals negative 4, x equals negative 1. So there are my solutions to this one. Right? And that was a little bit more work because we had to multiply out and then set it equal to 0 first. Alright, so 2 more. Now x squared minus 3 equals 0, you might say, oh, well, this isn't going to factor. This is actually one that you can do by a different method, which we would call the square root property. And why can I use what's called the square root property here? Because there's no x term. If there's no x term, right, and there's only an x squared term, I'm going to be able to very easily use the square root property. So in this case, I don't want to leave it in this form. What I want to do is I actually want to isolate x squared. So how do I isolate the x squared? I add 3. So I would have x squared equals 3. And now what I would do is I would apply the square root property, which says that I can take the square root of both sides of this. However, and this is something that you may not remember because a lot of times you don't really talk about it too much when you do square roots, but technically the square root of x squared is not really x, right? The square root of x squared is technically the absolute value of x, and the square root of 3 is 3. And if you recall, I'm sorry, the square root of 3 is not 3. The square root of 3 is just the square root of 3. Alright, so this is the square root of 3. However, if you remember when you solved absolute value equations, what did you have to do? You had to separate this then into x equals positive square root of 3, x equals negative square root of 3. So Honestly, do a lot of people do these equations the way that I just did this one? No. They just remember pretty much that when I'm solving an equation and I take the square root of both sides, I must take both the positive and negative square root of both sides, right? So that's a little thing that I can star here. Always take pos or negative square root. You got to take both when you're solving an equation, right? And that's something that's, I mean, it's a little bit confusing to a lot of people because, yeah, when you see this, right, if I see that, if that's my expression, the square root of 16, it's 4. If you see this expression, negative square root of 16, that's negative 4. However, when you're solving an equation, if you have to take the square root of both sides, you must take both the positive and negative, right? Not just one. So just keep that in mind. All right. So last one, 15 here. Now this is already set equal to 0, so, and it's x squared plus bx plus c. So what I could do is I could say, well, what numbers will multiply to negative 3 and also add to 3? And the answer is nothing. Impossible. There's no integers anyway that will multiply to negative 3 and add to positive 3. So it's not going to work. So I must use, in this case, quadratic formula. And what is the quadratic formula going to tell me? It's going to tell me that the solutions x are going to equal negative b plus or minus the square root of b squared minus 4ac. And this part, people, a lot of times people mess this up. The whole thing is over 2a. Right? The whole thing is over 2a. So what I've got to do here is identify what a, b, and c are, right? So in this case here, get rid of all this stuff. In this case, a, you don't see it, but there's really a 1 in front of that x squared. B would be 3, and c would be negative 3. So I just plug in now. So x equals, if b is 3, negative b, so negative 3, plus or minus square root. And now a lot of times I'll do more than, I'll do something here. I won't just enter it exactly. B squared is always going to be positive. So in this case, b is 3, so b squared is 9. And then I have minus 4 times 1 times negative 3. And this is all over 2 times 1. So this would be negative 3 plus or minus the square root of, and now this is where you got to be careful. It's 9, and now you count your negatives. I have a negative for the 4 here, and also a negative for this 3, so that's going to be really positive. 4 times 1 times 3, which is 12, all over 2. So I'm almost done. It's just negative 3 plus or minus the square root of 21 over 2. And now, can that be simplified? No. Right? Can't be simplified. And the reason it can't be simplified is that radical 21 is not going to break down at all. Right? Radical 21 can't be broken down. So there's my solutions. Right? Negative 3 plus or minus the square root of 21 over 2. And you got to realize here this is really two solutions, right? So it's negative 3 plus the square root of 21 over 2, and it's negative 3 minus the square root of 21 over 2. All right, so just keep that in mind. The plus minus means there's two separate solutions. Okay? And really, so what we did basically now is we did the algebra portion. All right? Now the second step in all the equations on the right side of this page would be the trig portion. Right? And just as a little quick example, go back to an easier one. The very first one that we did. Right? In number 1, the solutions we got were x equal 1 or x equal negative radical 2 over 2. So now how is that going to translate to number 2? All that happens is that x becomes the sine of x. So in other words, number 2, after I did the algebra, I would have boiled down to the sine of x equals 1. The sine of x equals negative radical 2 over 2. And really, that's, if you wish, you can do all these trig equations this way. Just start out by saying, all right, well, I'm going to call the sine of x just x. And I'm going to solve it algebraically first, and then I'll go back to the trig at the end. Right? In number 4, I'll say, all right, I'm going to call the cosine of x x. And then I'll go back and do the trig at the end. All right? So that's the algebra portion. Next time we will do the trig portion of these.